we will talk about econometrics versus machine learning. These are two fields we both are familiar with. We started with econometrics. We studied econometrics in our master's program, but later on in industry, we have used machine learning, right?
Yes.
So we
Yes.
will draw some parallels between these two academic areas. We will talk about the differences. We will talk about the similarities, and we will talk about some of the current trends in these two areas, right?
Yes.
Yeah. So when we studied our masters, we studied econometrics. There was no mention of machine learning in our master's degree, right? We never really
Yes.
learned any machine learning algorithm, although
Yes.
the econometrics models are also pretty much machine learning models actually,
Correct.
except
Yes.
maybe in the way they are used and implemented or they are built, but the theory behind them, right, is
Yes.
completely.
Fundamentals are basically the same thing. Yes.
Fundamentals are basically the same. You have linear regression in econometrics, you have linear regression in machine learning, you have logistic
Yes.
regression in econometrics, also in machine learning, right? You also have time series models in econometrics, also in machine learning, right?
Yes.
Question is why there are two academic areas. Do you know why there are two academic areas? Despite the fact that when we had statistics as a very well-developed field by the time machine learning, developed, it wasn't even a
Hmm.
field, academic field before 50s or 60s. It was
Yes.
new actually, but statistics was already an academic field by then.
Hmm.
You know why this was created? Because statisticians are mostly focusing on social science problems. They
Correct.
were
Correct.
mostly
Yes.
focusing on social science programs, except in few cases where scientific researchers also were using. For example, in
Hmm.
physics, statistical physicists used to use statistical algorithms, and many studies in biological science and medical science, they also use statistics. Okay, like clinical
Correct.
research
Correct. Yes.
or medical trial, randomized control,
Hmm.
right? All these things are very popular in medical science research also. But
Hmm.
statisticians were not solving problems in engineering, right? When it
Hmm.
comes to building products,
Hmm.
they were least interested. One example is
Correct.
disease recognition, right?
Hmm.
And banks were interested in this, and statisticians were not very interested in this. So I think some electrical engineer and computer scientists, they took this problem and they started thinking around it, and that's when machine learning actually, this field was actually developed, and
Introduce. Yes.
right, and it was back then developed by computer scientists, so it became a subfield of computer science,
Yes.
right?
Okay,
um,
so I think Pani, what happens is that so as you were saying that initially statisticians were very much focused on solving the social science problem. So I think the when you see the social science questions and when you actually translate it to the real life problem where the data set size is many fold bigger than what we have in the social science. So
right.
if you are talking about a country, collect all the data related to that population, it will be limited, right? But in the in when we talk about the machine learning, I think it is the concept might be the same. It is the scale. The scale is much bigger than what we have solved in our college time and in those things. So I think it is when you are expanding the scale from a smaller size to very big size where the computers are being trained on billions of data, right? The petabyte of data. So I mean that is what it makes that on the fundamental problem when it is solving a bigger problem on the bigger data set, might call it is a machine learning problem from general understanding perspective actually.
I
But the
totally agree. Yeah,
fundamentals which is being used in the background remains the same only, right? It's
yeah,
just that the scale on which it is able to solve the problem, which was not there in the normal statistician problem.
yeah. I agree. I agree. Because in social science, people use a few hundred observation, use
Correct.
data,
Yes.
and
Yes.
derive inference out of their
Yes.
model.
Yes.
But in
Yes.
machine learning, you have like tons of data, right? I think
Yes.
in terms of
Exactly.
capacity, computational
Hmm.
capacity,
Hmm.
the machine learning tools are more sophisticated and more suitable for data sets with millions of observations, whereas statistical tools are not that suitable. But there are also
Correct.
other differences. There are
Hmm.
type of problems actually, right? The type of problems. Like I have never seen a statistician working on image recognition. That is an area they are interested in. Statisticians are not
Hmm.
interested in image
Hmm.
recognition,
Hmm.
in machine translation, in language
Hmm.
models. Right?
Correct. Correct. Yes. Yes. Yes.
On the other hand, machine learning scientists are also not interested in randomized control trial.
Hmm.
Some
Hmm.
areas, theoretical part of time series analysis or panel
Hmm.
data analysis. I don't think machine
Correct.
learning
Correct.
are interested
Hmm.
in these sort of models, right?
Hmm.
Fundamentals are pretty similar actually because you're fitting the curve, right? You're doing the
Correct.
curve.
Yes. Yes. Hmm. I
Uh,
mean, Pani, when you look at the overall these problems, right? So broadly, they are basically classified into two parts. Either you have a regression problem or you have a classification problem, correct?
right.
And the basics of these two models, which we learned in our college, is the linear regression and logistic regression. But now you see, so many different kinds of model has come, but the basic is that they are also trying to solve the same problem. So if you talk about let's say the random forest, or let's say you talk about your the gradient boosting model, or XGBoost model. I mean, what they are trying to do, they are also trying to solve the same problem, right? If you have a classification problem, you can apply all these models, but the question is that these new models are actually lots of the complex methodology to solve the same problem. And in a way, they are actually giving you the better accuracy than what you could have got from a simple logistic regression, right? So
Logistic
maybe you can
regression
say that
is a
the basic.
regression model, by the way. So fundamentally, logistic
Yes,
regression
yes,
is a
yes,
regression
correct.
model
Yeah.
which can be used for classification problems. But
Hmm.
in theory, it's a regression model.
Yes, yes,
A
correct.
tree-based model,
Hmm.
right? Tree-based
Hmm.
models,
Hmm.
which are like decision tree
Yes,
models, or random
correct,
forest, so boosting or bagging, those models.
correct. Hmm.
Um,
Hmm.
you also
Hmm.
have these models in statistical learning, actually, statistical theory. But the way you build the model is also very
Hmm.
different in statistics as compared to that in machine learning. In machine learning,
Very different. Yes,
you build the model
yes.
in
I think
training
the
data set,
correct, correct, correct. Hmm.
and
Hmm.
you have a test data set to validate your model, right? I don't think any statistician
Yes,
do that,
absolutely.
right? Or econometrician will do
Hmm.
that, right? Building a linear regression model in a training data set and
Hmm.
testing its performance in another data set,
Hmm.
right? We were not taught
No, no,
about
no. Yes, yes, yes.
this
That
at university.
correct. Yes. So I
And
think the
also
one
there are
more
other
thing,
things,
Pani.
for
Yes, yes, yes,
example,
yes. Hmm.
testing the inference, right? Testing
Hmm.
the testing whether your estimates are significant or not. In machine learning, nobody
Hmm.
cares whether
Hmm.
your estimates are significant or not. As long as your prediction accuracy is good, the model is good, right? So what is
They are more
important?
concerned about the actual versus predicted than what is the significance level, what is the p value, and all those things, isn't it? Right? If you are
So it's the
giving me a very
accuracy,
high rate of accuracy rate, that's the primary focus they have, correct?
right?
In
Right.
machine
So
learning
accuracy
problem.
matters more than and it's because
Yes,
of the motivation behind building model, right? Statistician or
correct.
econometrician
Yes, yes.
to understand relationship between variables, dependent variable and set of independent variables.
Hmm.
So we want to know if a given independent
Yes.
variable changes by 5%, what will be the corresponding
Hmm.
impact on the dependent variable.
Impact on y
Whereas
variable.
in machine
Yes,
learning,
yes.
people only care about
Hmm.
the forecasting, the prediction part of
Overall accuracy of the model. Yes,
overall
yes,
accuracy,
yes, yes.
right?
Yes, yes,
So the
yes,
reason why you
absolutely.
build a machine learning model is a bit different from that from an econometric
Hmm.
model.
Hmm. I think on an overall basis, Pani, they are more focused on their outcome, right? How you are getting to the outcome, that's not their concern, right? If you work on a real life problem, right? I mean, a person in Google trying to figure out which Gmail, mail should go to spam versus non-spam.
Right.
They are more focused on the outcome. They doesn't care what independent variables we are using. Actual output should be matching with what actually is the truth. Basically,
The
if
accuracy. Yeah.
your model is able to classify the spam message correctly by 99%, company doesn't care about what model you have used, whether you use a normal regression or whether you use a random forest or bagging boosting, no one cares.
Right.
So in practicality, the outcome is always about accuracy. How model is predicting, more accurately. That's the only concern. P value and significant and all those things. Whether you are using 10 variables or 100 variable,
Nobody cares.
list of concern for them, right? No one
Right.
cares.
Yeah.
Exactly.
So that's not the thing in all industry, by the way. For example,
Yes.
you think
Yes.
in finance,
Hmm.
these things do matter, right?
Yes. Yes. Yes.
Your
Yes.
models should be theoretical good. It's not just
Hmm.
about
Hmm.
prediction accuracy. It's also
Hmm.
about whether you have taken good variables, whether they're monotonic or not,
Correct. Yes.
they
Yes.
make
Yes. Yes.
sense in the model or not, whether the sign of the estimate is as
Correct. Yes.
expected or not. So there are many things that do matter, right?
And if the
Finance.
variable is making business sense or not, right? In finance, it is also very important, right? That variable should make a business sense. Otherwise, sometimes what happens, a statistician, right, data scientist develop a model, they go with that model to the business. A business says, oh man, this is a useless variable. I don't want this in the model, right? It doesn't help to differentiate between good and bad. So from that point of view, it will be excluded.
Right.
But I mean, in other industries, like I was talking about that text classification thing. I mean, these things are of least of importance, right? Their
Exactly.
more focus is on a few metrics, which is either you call it a recall rate or precision rate or accuracy rate. Those things are much more important than your this what variable you are using. You can use hundreds of variables. That's why machine learning these days have become very sophisticated, where I think number of features or number of model you develop, right, it's not of concern. Because you see in the random forest also, right, you can build a simple decision tree, which will just build one simple decision tree
Right.
based on your sample. But when you go for random forest, it creates hundreds of trees, right, and then try to take the the maximum frequency count based on voting, whichever is combination is
Right.
giving
Right.
you the best output, like that. So
Right.
I think the computational cost is also high, and some of the old companies who are very, very slow in advancing their upgrading their backend technology, which is
Right.
also not allowing you to implement these new models, right? So they are still stuck at those classical models like normal decision tree and normal logistic regression, like that.
Let
So
me
that is
let
all
me
another one.
take this. Yeah, you said about implementation. I
Yes,
think
yes, yes,
implementation challenges are there in almost all industries. It is not just
yes,
limited
yes.
to the traditional industry or the old company. I have spoken
Hmm,
to many people who have developed very
hmm,
sophisticated ML models, but
hmm,
when it came to implementation, the
hmm.
challenges were so many that they had to
Correct.
finalize a very
Hmm.
simple regression sort of a model.
Correct, correct, correct.
So
Yes, yes.
yeah, implementation is a challenge because
Hmm,
if you have, let's say, hundreds of variables in a model,
hmm, hmm,
to be able to get data for these 100 variables properly
hmm.
is very big challenge, right? In production,
Correct, yes.
of
Hmm,
issues. Something goes wrong
hmm.
and you could have trouble, right? So
Correct, yes.
something is a big challenge actually for ML models. Only the big company, like big tech company, Amazon, Google,
Yes,
or even the many startups actually are able to do that.
correct, yes.
Primarily because I think they are more agile in a way, and
Yes, yes. And
secondly,
their technology is new, so they are able to,
exactly,
upgrade the system. It is
they are
very
able
on a
to
small scale, right? Yes.
exactly. And for
Hmm.
big companies to get rid of the legacy system is
Very
not
difficult. Very difficult. Yes.
right. So I think
So
that's another challenge.
yeah. So one matrix just wanted to highlight, Pani, here. Recently there was a training conducted in my company. Okay, and the trainer was actually talking about the AI system. How so if there are 100 company which is working on creating some AI product in their company, right? What percentage of those AI projects are actually, finally successful and implemented? Okay. And you'll be really surprised to know it is just 20%. So if
Yeah,
there are 100 companies working on AI projects, right, it is only 20 company which is actually able to create some final product and able to implement something on their system, right?
exactly.
80% of them are failing. Either their model is not that accurate, what the business might have expected, or they don't have the system in place to implement that kind of, the advanced models
Right, right,
which will support them, right? So that's the also a thing, so many times you'll find that you are developing something very extraordinary, but your company doesn't allow you or is not ready to take that kind of models for
right,
implementation. So that is another thing I just wanted to highlight.
right, right. I think you can learn from both areas, right? There are some pros and
Mhm.
cons in econometrics, so is
Yes.
in machine learning. The good thing
Yes.
about the econometric approach of building models is that you really understand the model very well. It's not a black
Yeah.
box,
What is going on in background? Yes.
right?
Yes.
So if
Absolutely.
something really
Yes.
happens in production, for
Hmm.
example, if the
Hmm.
model is not
Hmm.
performing very well in the production, you can actually
Hmm.
understand the reasons behind it very well if
Hmm.
you have
Hmm.
built a very solid from a theoretical point of view, very solid model, keeping in
Hmm.
mind, yeah, the estimates and how estimates vary with, with changes in the variable, all these things, very theoretical aspects.
Correct. Correct. Correct.
And I think it is easier to understand the models very well, and you can fix the issues. I think that's something that ML engineers should actually learn from econometricians or statisticians. It's not just about engineering, it's also about science, right? Science behind the model.
Yes.
We're
Hmm.
calling it as,
Yes.
people are calling themselves as data scientists, but they're working as actually. They do not
Correct.
really
Yes.
understand the theory behind the models.
Hmm.
And I think the
So
freshmen, people coming into this field, many of them do not really understand the basics of modeling, like basics of linear regression, basics of
correct. Correct.
algebra,
Hmm.
and they
So
straight away go to importing some libraries,
libraries in Python. Yes.
Python, and build
Yes.
models. That's
Yes.
that's not modeling actually. That's something can do, right? You can
just
automatically
just doing fit
model.
and predict. That's it. That's the only knowledge they have. What is going on in background doesn't have that knowledge, right? Yeah. Correct. Yeah, I agree with
Right?
you.
And on the other hand, I think econometricians can also
Hmm.
learn from machine learning engineers in many
Yes.
ways
Yes. Hmm.
in order to build model using huge amount of data,
Yes.
right?
Huge amount of data. Yes. Yes. That's
Building
the
models
future.
using unstructured data, something that
Hmm.
econometricians simply won't do, right?
Oh, on to correct. Absolutely. They need a
Another thing is,
structured data in a tabular format with few columns and the target variable well defined. Then only they can start working on that. And I
right,
think I think the gap is from both the side, right, Pani, as you explained. So the basic, the statistician or econometrician might be very strong with the fundamentals, right, which is going on in the background, like basic regression, logistic regression, what are the assumptions, everything they are very strong. But on the technology side, right, how to implement this concept over a very vast scale, right, billions of rows of data, unstructured data, like you pointed. I think that is where there is a gap. So these guys are very good at the fundamentals and all those things. They can even work on the it's smaller data set. They can implement that thing. But when it comes on a bigger, larger scale of that problem, I think that is where they need to, I think, improve their skills there. On the other hand, these machine learning guys, they are very good at the computing and working with the large amount of data, but they are lacking that fundamental part, which a statistician has. So if some team is formed which is combination of very good engineers who have very good command on the
theory part,
this yes, theory part,
theory.
and the guys who have a very good command over handling the huge amount of data, and I think that will be the deadly combination, right? They can crack really good things. Yeah, big problem.
Yeah, yeah. There are other things also
Hmm.
econometrician can learn
Hmm.
from machine learning engineers, which is
Hmm.
that finding out problems which are engineering related, like developing products.
Hmm. Hmm.
Right? It's not just about social science problem that statisticians should
Hmm.
actually focus on, right?
Hmm. Hmm.
Even non-social science problems are important for the society, and statistics being a very scientific subject, it should not only
Hmm.
be limited to social science like political science, economics,
Correct.
sociology, right?
Hmm.
Psychology,
Hmm.
these
Hmm.
geography, these areas,
Hmm.
statisticians can indeed solve problems in computing in digital space. And
Correct. Correct. Yes.
that also when they build model, I think it's important to do this cross validation things,
Yes.
right?
Very important. Very
Because
important. Yes.
many
Hmm.
economists, they what they will do is that they will draw their conclusion based on exactly the same data on which they build a model, which is
And don't.
okay because
Hmm.
people won Nobel Prize using that,
Correct.
because they
Huh.
don't really care about predictions as such. They only care about
The theory
uh,
part. Yes. Yes.
estimate, right? The
Yes.
estimate on the marginal effect, all
Correct.
these
Yes.
things. But even there, I think cross validation is important. I was going through a paper by
Hmm.
Harvard, the
Hmm.
microeconomist who,
Yes, the guy who wrote that, the famous microeconomics books which we read in our masters, right? You're talking about that person, Paul
yes,
Harvarian.
yes, yes,
Oh, yes, yes.
Harvard,
Okay.
and
Hmm.
he also worked at Google for some
Okay.
years. He was the
Oh.
chief economist there, and he came
Oh.
across machine learning over there.
Hmm.
And after a few years, he wrote a book. I think not a
Hmm.
book, but a paper.
Hmm.
Uh, what econometricians can learn from machine learning. Okay,
Okay. Hmm.
so that's a wonderful piece of paper. I also came across a paper on Harvard University's website
Hmm.
where people have discussed about the similarities and dissimilarities between
Hmm.
these two fields and what
Hmm.
people can learn from each other, right?
Yes. Yes.
So
Yes.
I think that's quite important. But I think for the
Hmm.
young people, right, the young
Hmm.
people coming out of university who are starting out
Hmm.
data science, I think
Hmm.
for them to go through a basic econometrics book is something I will advise, because in machine learning you do not really put a lot of emphasis on understanding the mathematics
The
behind
fundamental part. Yes. Yes.
it,
The
right?
fundamentals. Yes. Yes. Hmm.
Understanding of some theory actually really help,
Hmm.
especially the algorithms, right? Classical linear, what is that called? CLRM, right? CLRM.
Hmm. Yes. Yes. Yes.
Understanding
Hmm.
of those assumptions is very, very important, because that's a foundation. You build on that,
Correct. Hmm.
because
Yes.
end of the
Yes. Yes.
modeling is
Absolutely.
nothing but a curve fitting actually.
Yes. Absolutely.
And
Hmm.
you use whatever sophisticated models at your
Hmm.
disposal, but it's nothing but fitting a curve to a data.
Hmm.
That's something
Hmm.
can be using a linear regression also.
Hmm. Hmm.
It's the most basic form of modeling. And
Hmm.
if you really understand that, right, the theory behind it, right?
Hmm.
I mean, you can understand what is heteroscedasticity, what is
Hmm.
homoscedasticity, what is multicollinearity, what,
Yes.
why normality of error is important in order to be able to build a good model, right?
Hmm. Hmm.
All these things are quite important. If you understand them, I think it is easier for you to understand more sophisticated models, and you can also
Yes.
see difference between these two models very well. It's not just about
Hmm.
which Python libraries to be used for random forest, which one to be used for support vector machine. That's not good enough, right?
Yes. 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 Absolutely. Yes.
Yeah, and I think, but to me, for a lot of the problems in banking and finance where regulation is not there,
Hmm.
can explore the advanced machine learning and AI models. For one example is the anti-money laundering or financial crime,
Hmm.
where
Yes. Like
you have
the fraud
tons
and
of,
all, right? Yeah. Fraud also, right?
yeah, you have tons of data, tons of
Yes.
data, because
Yes.
you
Yes.
use transaction data, and like
Hmm.
millions of transactions happening every day.
Hmm.
So like
Hmm.
hundreds of millions of observation at your disposal,
Hmm.
and then like
Hmm.
thousands of variables, and how
Hmm.
to make use of this data to build
Hmm.
good models, right? And
Yes.
uh, when you have uh, that kind of data,
Hmm.
not rely on simple models like linear regression.
Yes. Yes. No. No.
Should explore
Yes.
more
Hmm.
sophisticated models, ML,
Hmm.
right?
Hmm.
And that's something I have come across in many companies.
Yes. So I also actually saw that problem there in SBI Guide Finding. So what happened? They have this problem of fraud detection. Okay, and what I realized that many of these companies, since they are having the tie up with the credit companies, right, where they have to share the the data to these credit bureaus, right? So what happens? Actually, credit bureaus take advantage of this data. Okay, they get the data from all the financial institution as mandated by the RBI in India, right?
Right.
I think it will be the same case in other country, right? They will be mandated to share at least with two, three bureaus. So what
Right.
happens? They get huge amount of data, right? SBI card itself don't have that amount of data, right? They have the fraud detection data from their own customers, okay? But what happens if it is the fraud detection from ICICI, MX or SDFC, something like that? So that way, these credit bureau companies get huge amount of data on fraud, and they try to build a very sophisticated model using these combined databases, and they actually sell those models to these companies, okay? Because they don't have that capability to collect all the data, because and they don't have that capability to develop that that kind of very complex model. So what I realized that they are earning a lot of money by selling these models.
Yeah.
So SBI Card had a third party model from one of these bureaus, right? And we were
Like
using
what?
that to yes to detect the fraud transaction. So when application comes, it is one of those score which runs on fast, right? Just to filter out if these guys
Right.
had made any fraud transaction in any of the banks or financial institution in India, and it becomes very easy. They don't even pull the score; they just decline. Right away there. So I think it is a very good scope as you mentioned, and then there is no regulation. So that is another thing. You can try anything you want, right? Whatever the complex model, as long as it is fitting, it is able to predict your fraud as accurately as possible. Then I think you are good to go, right? Yes.
Yeah. Good.
And I think it will also save a lot of money for them, isn't it? Because if the production is in-house, you don't have to pay that crores of money to the third-party company for getting that score, right? So in credit risk domain, it is all about buying those scores from the these bureaus, and these bureau charge huge amount of money for those fraud score, for the normal the risk score and everything.
Yeah.
So yeah, I think
Let
that
me
is a
share
whole.
with you my screen.
Hmm.
And I'm going to show you a paper that came across on Harvard University's website.
Mhm. So is it regarding that the comparison of our the machine learning models and the normal statistical model or fundamental of statistics, or what?
Yeah, it's about comparison between machine learning to statistics.
Oh, okay.
So this is written by, I think, Mulainathan, Sandil Mulainathan. I think he's a development economist, if I'm not wrong,
Hmm.
in MIT or something.
Hmm.
And the name of the paper is Machine Learning and Applied Econometric Approach.
Okay.
And it goes like this. Machines are increasingly doing intelligent things. Facebook recognizes faces in photos. Siri understands voices. Google Translate
Voices.
website. The fundamental insight behind these breakthroughs is as much statistical as computational.
Computation.
This is very
Yes.
important. So statistical side comes from the econometrics, whereas computational side comes from the machine learning, right?
Correct. Yes.
Machine intelligence became possible once researchers stopped approaching intelligence tasks procedurally, which is normal programming, right? Where you actually
Yes.
ask computers to do things, whereas AI or ML is more about asking the system to do without even providing instruction. Began
Yes.
tackling them empirically. Face recognition algorithms, for example, do not consist of hand-waved rules to scan for certain pixels. Right now, we don't have this. It used to be the case, right? Indeed, these algorithms use a large data set of photos labeled as having a face and not to estimate a function fx that predicts the presence of y of a face from pixel x. This similarity to econometrics raises questions. Are these algorithms merely applying standard econometrics techniques on large data? At the case, or if there are fundamentally new empirical tools? This is also a question he's asking. How do they fit with what we know? Okay, what we know, as in what econometricians know.
Correct.
We present a way of thinking about machine learning that gives its own place in the econometrics toolbox. Central to our understanding is that machine learning not only provides new tools, so the answer is there are tools, it solves different problems. That's what we were talking about, right? The problems
Correct.
machine are tackling are totally different. Machine learning, or rather supervised machine learning, revolves around the problem of prediction, right? Prediction is the key there. Prediction
Correct. Yes.
of y from x. The appeal of machine learning is that it manages to uncover generalizable patterns. In fact, the success of machine learning at intelligence tasks is largely due to its ability to discover complex structure.
Hmm.
That is not specified in advance. It manages to fit complex and very flexible functional forms to the data without simply overfitting, right? So overfitting is the key in machine learning, and I'm
Correct. Yes.
thankful that this econometrician has even used it once, because we never really
Hmm.
learned about overfitting, right? In a standard economic.
Yes. Hmm.
Many economic applications instead revolve around parameter estimation. That's what we also discussed, right? Statisticians
Yes. 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 They're
only
concerned about the X variables.
estimates,
Yes. Hmm.
produce good
Yes. Yes.
estimates of beta parameters
Correct.
that
Yes.
underline the relationship between y and x, dependent variable
X.
and
Hmm.
independent variable.
Hmm.
It is important to recognize that machine learning algorithms are not built for this purpose. Machine learning algorithms
Hmm.
are built for XY's relationship, right? For example, even
Hmm.
when these algorithms produce regression coefficient, the
Hmm.
estimates are rarely consistent, which something
Hmm.
we have seen, right? The danger in using these tools is taking an algorithm built for y hat, which is the
Hmm.
predicted value of y, and
Correct. Yes.
predicting that beta hat
Hmm.
have the properties we typically associate with estimation out. Of course,
Hmm.
prediction has a long history in economic research. He is all acknowledging that in predictions are also important in economic research, especially in
Hmm.
finance, right? Predicting
Hmm.
stock prices and stock returns. Of course, prediction
Hmm.
has a long history in economic research. Machine learning provides a new tool to solve this
Hmm.
old problem.
Hmm.
What he's saying is the machine learning will complement that. Put
Correct.
sufficient, sorry, put
Hmm.
simply, machine learning belongs in the part of toolbox marked y hat rather than in the more familiar beta hat compartment. Beta parameters are less important, y hat
Hmm.
prediction is more important. Let's go
Hmm.
further. This perspective suggests that applying machine learning to economics requires finding the relevant y hat tasks. One category of such applications appear when using new kinds of data for traditional questions. For example, in measuring economic activity using satellite images or classifying industries using corporate 10K filings. Making sense of complex data such as images and text often involves a prediction pre-processing step. In another
Hmm.
category of application, the key objective of interest is actually parameter beta, but the
Hmm.
inference procedures contain a prediction task. For example, the first stage of linear instrumental variable regression is efficiently prediction. The same is true when estimating heterogeneous treatment effects, testing for effects on multiple outcomes of experiments, blah blah blah. Okay, so the point here is that he's trying to say is that prediction can
Hmm.
certainly be used in econometric model development, because in many areas of economic research you do care
Hmm.
about prediction, you do care about the y hat, you just do
Hmm.
not care about beta hat.
Yes.
The
Yes.
beta parameter.
Yes. The coefficients of X. Yes.
Exactly.
Hmm.
Machine learning
Hmm.
algorithms are now technically easy to use. You can download conveniently packages in R and Python that can fit decision tree, random forest, lasso, regression.
Hmm.
This is
Hmm.
this also raises the risk that they are applied naively and their output is misinterpreted. Right? I
Hmm.
don't agree, but okay. He's saying that okay,
Hmm.
because people non-econometricians have implemented these algorithms on R and Python. I think it may be the case that these are not properly interpreted. We hope to
Hmm.
make them conceptually easier to use by providing a crisper understanding of how these algorithms work,
Hmm.
where they excel and where they can stumble, and thus they can be most usually usefully
Hmm.
applied.
Hmm.
Right. So the point here
Yes,
is
I
that
think. Hmm.
they
Hmm. Yes. Yes. Please
acknowledging
go.
the good
Hmm.
things about machine learning, right? Even though he's a
Hmm.
social scientist,
Hmm.
but he's acknowledging that. But I know this guy, Sendil Mulyanathan, the professor.
Hmm. Hmm.
He has a computer science background. I think he did his bachelor degree in computer
Hmm.
science,
Hmm.
but he did his
Hmm.
PhD in economics in MIT.
Okay. Hmm.
So the point here is
So
that
hmm. I
he's
think he
recognizing
is
the good
also.
things in this.
Hmm. I think he's right because funny if you see these libraries like the one of the most used library in Python for data science, right? Scalar, right? So what happens when you so in college you remember when you used to do a simple basic models using I think we were using something called stata at that time, or views, right? So whenever you estimate a model, what do you get as the first thing? You get a, the beta estimate linked to X variable and their,
Right.
basic stats, like what is the coefficient, what is the p value, what is the, the variance and the class interval, right? All those basic stuff you get, standard deviation and all those things. But when you fit in the regression in sklearn, it's very difficult to get the p value. You will get the coefficients estimate and everything. It seems like those who have created the sklearn, they didn't care about the p value. What is the p value for this variable? It becomes very difficult to figure out where is the p value, man. And that's why, I mean, what he's saying actually making sense, because these people are not concerned about whether this particular variable is, significant also, right? If it is going to hold in the future or not, right? In a different data set. They just estimate a model, even if including 20 variables, it gives some result, and as long as it is able to
Prediction is
fit on
important.
the,